Hello everyone and welcome to another reviews video tutorial. My name is Juan and today I'm going to be covering the topic structural vector autoregressive models in EViews, and in this particular case I'm going to be emphasizing on the long run restrictions. I just want to clarify that for this video I'm not going to be emphasizing too much in the algebra, but what we are going to be doing is replicating or working on a model inspired by Anderson Lee 1997, where they decompose the exchange rate movements. Um, and the idea for this is that I'm going to show you how to do this in EViews, and I'm going to explain you some of the things that you have to take into account when estimating this type of models. So let's begin with our analysis. Let's begin with an introduction. We're going to talk a little bit about the difference between a reduced form VAR and a structural VAR, and the main difference is that innovations in a reduced form VAR do not have a direct economic interpretation. Structural VAR models rely on economic theory to sort out the contemporaneous link between the variables in our model, so some identifying assumptions are required. Structural VAR models are used for monetary and fiscal policies analysis. The reason for this is because structural VAR models allow us to impose an ad hoc structure that will prevent us from reaching to wrong conclusions. So just to put an example, imagine that we can picture that our economy output is going to be decreasing. So the government increases the public spending, and after increasing the public spending, we see that output continues to decay, and maybe we can associate or link this with public spending has caused our economy to collapse, and maybe that's not a correct conclusion. Maybe what we can do in that type of situation is including some ad hoc restrictions that will prevent, these undesirable results from happening. So let's review some examples. A long-run restriction is commonly associated with the concept of long-run neutrality. Classic macroeconomic hypotheses specify that in the long run, permanent changes in nominal variables have no effect on real variables. Just to put some examples, let's review the first case is, for example, permanent changes in the nominal money stock has no effect on the level of real output in the long run. You can picture an extreme case like Venezuela. Maybe you may think that, printing money in the long run, you're going to be a rich economy. You're going to be able to alter or affect the output. But only what you're going to see is that if you print money in a systematic way, you're going to be just modifying the prices, but you're not going to see, a difference in the real output in the long run. Another example can be permanent changes in the rate of inflation has no long run effect on unemployment. You can picture a vertical Phillips curve in the long run. Lastly, permanent changes in the inflation rate has no long run effect on real interest rate. You can picture the Fisher relationship in the long run. Let's review some of the literature using long run restrictions. We have to mention that Blash and Arquin in 1999 have proposed this alternative set of restrictions, the long run restrictions, that have been used by several authors. So the first example I have written here, of course, is Blanchard and Qua, the dynamic effects of aggregate demand and supply disturbances, where basically the authors have used two variables, GNP, which is the gross national product, and also unemployment, and they have imposed the long-run restriction where they have mentioned that, for example, nominal shocks will have no effect on the output in the long run. Yes, that's a very valid restriction that you can impose in your identification strategy. So then we have King and Watson in 1997, the paper testing long run neutrality. We have the paper that we're going to be reviewing today, Anderson Lee 1997. Again, as I mentioned, I'm going to be inspiring the results that we're going to be finding in this paper. And lastly, we have Gali 1999, Technology, Employment, and the Business Cycle. And this is a really interesting paper where basically the author is going to mention that only technology shocks are going to be the shocks that will have a permanent effect. So I want to mention that just to put a very brief idea, a very general idea of what this type of restrictions are, is just imposing that real shocks will have permanent effects on the real variables, but nominal shocks will have no permanent effects, of course. Yeah, so that's basically what you have to picture in your mind. Okay, so now let's go to, sorry about this. So now let's go to our example. We have um, exchange rate movements decomposition, and we're going to be seeing how real and nominal factors affect exchange rate movements. So as I mentioned, we will decompose real and nominal exchange rate movements into the components produced by real and nominal shocks. The topic is inspired on the paper written by Anderson Lee in 1997, and the intention of the authors is to explain deviations from the purchasing power parity. And this is, as a note, I put here, PPP is used to calculate the exchange rate between different countries for the purpose of exchanging goods and services of the same amount. So there are going to be two shocks affecting the exchange rate movements. These are going to be nominal and real shocks. Real shocks can cause permanent effects in the real exchange rate, but nominal shocks can only affect the exchange rate in the short run. So just picture a country that doubles their money supply. Price level and nominal exchange rate will double in the long run. However, the real exchange rate will remain unaffected. There are some important considerations that we need to keep in mind when working or trying to impose long-run restrictions within an SVAR framework. And this is that we need a variable to be I1, yes, and this is because we require that permanent effect. So in order to use long-run restrictions within a structural VAR framework, at least one of the variables in our system needs to be non-stationary. It cannot be stationary in levels. It has to be, stationary in differences. So for further details, you can definitely take a look at one of the papers I have included in the description of the video. It's King and Watson. But if you're asking why do we need this requirement, is basically if the data that we're using is stationary in levels, the long-run impacts of shocks to the level of the series are always zero. So in other words, stationary variables in levels have no permanent components. Yes, we require the variable to be stationary in differences, to be able to have this permanent effect. So just as an important note, although we require one of the variables to be non-stationary in levels, when we are estimating the models, the variables must be in the stationary form. This is, for example, applying differences. Let's review the data that we are going to be using. The original paper uses monthly data for the years 1972 to 1992. The variables they have used are nominal exchange rate, real exchange rate, and wholesale prices. And just as a note, real exchange rate is calculated using the nominal exchange rate and the wholesale price ratio. The countries considered in their paper are Canada, Japan, and Germany. But for the purpose of this video, I'm just going to be replicating the results for Japan. I'm going to be using quarterly data instead of monthly data, and I'm going to be extending the period until the year 2019. The dataset is in the description of the video. Please feel free to download it. And I have already cleaned and worked on the dataset. I have already put for you the real and the nominal rate. But if you have any questions on how to get or how to get to this dataset, just feel free to email me, and I can definitely give you some instructions on how to prepare this dataset, okay? So step number one in our analysis will be reviewing if our variables are stationary. As per you mentioned, at least one of our variables has to be non-stationary in order to use long-run restrictions. Reporting the stationarity test in your paper will be relevant. So if you are doing a paper, you are using a structural VAR with a long-run restriction, as this is a requirement, you will definitely be interested, in reporting these results. The authors, they have done a graphic analysis, and then they have included an autocorrelation table and the augmented Dickey-Fuller. The values that they have reported for both the autocorrelation and the augmented Dickey-Fuller test, they are variables using variables in logs. And as I mentioned, recall that although one of our variables need to be non-stationary, when estimating the model, we need to use the variables in their stationary form. This is, for example, applying differences. We are in EViews. Here we have our variables for Japan, which is the real exchange rate, the nominal exchange rate. The dataset goes from 1973 to 2019, and as you can see, this is quarterly data. The first thing that we're going to do is to reproduce the graph We're going to select the nominal and the real exchange rate, and we're going to select open as a group. And now we're going to go under view and graph. We're going to hit OK in the first option. And here what we can see in our graph is that over time the mean has not remained constant. This already is an indicator that our data is non-stationary, but we will definitely be complementing this with the autocorrelation function and also with the augmented Dickey-Filler test. And the authors have edited this graph in a way that it should be looking like this. I'm going to show you right now. I have already saved the graph. And this is the way that the graph looks when the authors have reported it in their paper. The way that you would edit a graph like this is just by clicking doing a right click, going under options, and here you will be playing around. I invite you to start trying here different options and making the graph look this way. If you still have questions, please feel free to send me an email or comment, and I will teach you how to edit the graph to make it look in this way like the authors have done in their paper. The step number 2 is now converting our variables from the nominal and real exchange rate into logs. We're going to do that transformation. We're going to select generate. We're going to type ln. This is the way I'm going to call my nominal exchange rate in logs. And I'm going to type log, open parentheses, type nominal. And here I have transformed my nominal exchange rate into logs. And now let's click generate, do the same for real. And now we have both our nominal and real exchange rate into their corresponding logs transformations. Let's continue our analysis by checking the autocorrelation function of our real exchange rate in logs. I'm going to open the variable, I'm going to hit in view, go into correlogram, and leave it in levels. What we can see here is that in the autocorrelation function, this decays in a very slow pattern. Reason why this is already indicating that our variable is non-stationary. We have seen in the graph that the mean had changed over time. The autocorrelation function is decaying in a very slow pattern. If it was decaying in a fast pattern, it would be something like this. Okay, but this is not what we see in our autocorrelation function for this case. Let's finish our analysis by taking a look at the augmented Dickey-Filler test. We're going to go into view, unit root test, standard unit root test, and we are going to hit in levels the augmented Dickey-Filler test. And we can see here that the null hypothesis of the test is that the exchange rate has a unit root. Because the p-value is bigger than 0.05, this is the 5% level, we cannot reject our null hypothesis. The null hypothesis is that the variable has a unit root. Reason why, if we cannot reject it, what we are saying is that our variable is non-stationary. So we have proved that the real exchange rate in logs is non-stationary. The last thing that we want to check now is whether our variable is stationary in first differences or not. So we're going to go into view, unit root test, standard unit root test, and we're going to now perform the augmented Dickey-Filler, but in first differences. We hit OK, and now what we can see here is because our p-value is smaller than 0.05, this is at the 5% level, we can reject our null hypothesis. If we reject our null hypothesis, we are saying that our variable in differences is stationary. Now I invite you to check and do the same process for our nominal exchange rate. I want you to open in EViews and check the correlogram, the augmented Dickey-Filler, and verify that the nominal exchange rate is also non-stationary, and apply first differences, and also verify that the variable now will be stationary in first differences. Moving next, in this slide I'm showing you the graph. In the left we have the replica, the graphic that we have reproduced in EViews, and on the right we have the graphic from the original paper. Just recall that our data is quarterly and the data of the original paper is used monthly data, and also that the period it goes until is the year 1993, and in our case we have extended the dataset until the year 2019. So this until around this part, this would be the replica to the left, but to the right, all this part is the extension of the dataset. So something important to mention in this graph, and that's basically the idea what we are trying to analyze in here, is that we can see in the short run there is a shock that is affecting the real and the nominal exchange rate in a similar pattern. We see that both real and nominal are moving very closely together, but in the long run we can see that nominal and real exchange rate, they diverge. So again, there's one shock that is affecting the exchange rate in a similar pattern in the short run, but another shock that is acting in a different way. In this slide, I have reported the autocorrelation table. As I mentioned, this is something the authors have done, and it's also something important for you to report if you're writing a paper using this type of identification strategy, because as I mentioned, it's important to show that your variables, at least one of them, is non-stationary levels. I have reported here nominal and the real. Well, this JY means the Japanese yen. And we can see here that because these values are decaying in a very slow pattern, 98, 96, 94, 91, this is already telling us that our variable is non-stationary. And moving to the next slide, I have reported the augmented Dickey-Filler test results. This is also something that you will be interested in reporting in your research paper. Here are the variables, the real and the nominal exchange rate. And basically here, just the main result we are going to be taking a look at is the stationarity. We have concluded that both our variables are non-stationary. It's now time to estimate our VAR model in EViews. Now that we ensure that our variables follow a unit root process, but they are stationary in first differences, we proceed to estimate the model. What we're going to be doing is estimating the VAR model using the real exchange rate and the nominal exchange rate in logs and differences. We will then select the appropriate lag length using a lag length criteria. In this case, we would take a look at the Schwarz, Hannan-Quinn, Hanakaike criterion. And then we are going to re-estimate the model using the correct lag length. Finally, we're going to do the structural factorization, and we're going to impose the long-run restriction and obtain the results. So now let's go to EViews and estimate our model. We're now going to estimate the model in EViews. Recall that our variables in level are non-stationary, but in differences they are stationary. So we're going to be estimating our model using logs and in differences. We're going to open our model. We're going to start with the real exchange rate and the nominal exchange rate in logs. We're going to open this as a bar. And we're going to apply the difference in here. We can just type D, open parentheses, close there, and then we put a D before the log of the nominal exchange rate. So this is what you have to do. We're going to leave this as a standard VAR model. We're going to leave 2 lags for now, just as a default, but we're going to be, in the next step, looking what is the correct lag length. We hit OK, and we can see here the estimation output. Here, and the standard errors are in the parentheses. The statistics are reported in the square brackets, and here we have the estimation output, as I mentioned, and the lags of both the real and nominal exchange rate. We're not going to be taking a look to match now at this output for now. We're going to just select view, and we're going to take a look at the lag length criteria. In the lag structure, you're going to select lag length criteria, and we're going to see what is the correct amount of lags that we should be including in our model. We have a Kaike criterion, Schwarz, and Hannan-Quinn. These are the most commonly used lag length criteria. And here is telling us the amount of lags, 0, 1, 2, 3, 4, etc. With the stars, we are seeing, for example, that the Akaike is suggesting us to use 3 lags. Schwarz criterion is suggesting us to use 1 lag. And finally, the Hannan-Quinn is also suggesting us to use 3 lags, okay? So just guiding by this, by the Akaike and the Hannan-Quinn, both are suggesting me to use the 3 lags. So for now, what we're going to do is to re-estimate our model. We're going to select estimate button here, and we are going to click 3 lags. Now we have re-estimated our model. using the correct amount of lags. We can check under view. We can go under residual test, the correlograms. And here what we can see is that our model, the autocorrelations are within the two standard error bounds, as you can see in here. This would be the bounds, and you can see that these values are all within the two standard error bounds. In this slide, I'm going to show you what we are doing with imposing the long-run restrictions. So the first 2/1 vector is the real and the nominal exchange rate, okay? And they are in first differences. Then the last 2/1 vector represent the zero mean, mutually uncorrelated real and nominal shocks. The main matrix in here are the coefficients that represent the time path of the effects of the real and nominal shocks on the real and nominal exchange rates. So for example, the first line is for the real exchange rate in first differences, and this is how a real shock is going to be affecting the real exchange rate, and the nominal shock is the cumulative effects, okay, of the real and nominal shocks on the real and nominal exchange rate. So the long-run restriction implies that the cumulative effects of the nominal shocks on the real exchange rate are zero. So formally what we are imposing is that the cumulative effect over time, yes, on this element, okay, is going to be zero. Again, we have the shock, the real shock will have an effect, a permanent effect, but the nominal shock in here, the cumulative effect will be zero. We're now back in EViews, and I'm going to show you how to estimate the model by imposing the long-run restriction. So you're going to go into proc, we're going to go into estimate structural factorization, and now we're going to be selecting from the restriction, preset options. We're going to be selecting the long-run restriction. Okay, you have the short-run restrictions. We have here the long-run restriction. As you can see, what is showing you here is basically what I mentioned you in our slide. The cumulative effect of the nominal shock on the real exchange rate is going to be zero. We're going to select OK. And here now we have the output. We can see just quickly that here is what we have imposed in the matrix. The cumulative effect, as I mentioned, of the nominal shock is going to be zero. We have the estimate coefficient estimates here, okay, for C1, C2, and C3. And here we have the structural matrix, okay, for the estimated S matrix and the F matrix. Here we have the reported values. We're going to continue our analysis by displaying the impulse response functions. I'm going to select impulse. I'm going to go to 34 periods. That's how much I would like to show the responses to the shocks. I would like to see the shocks in combined graphs. I would like to see both the real and nominal shocks, how they affect each of the exchange rates. And I'm going to select accumulated responses to see how these shocks accumulate over time. We are going to go into Impulse Definition tab, and we are going to ensure that we select the structural decomposition. We select OK, and here we have our graphs. On the top, we have the accumulated response of the real exchange rate, and on the bottom, we have the accumulated response of the nominal exchange rate. Shock number 1 is the real shock, and shock number 2 is the nominal shock. I'm going to be doing a deeper analysis in the next slide. In this slide, I have reported the impulse response functions. Here is our replica, and here is a picture of the original paper. And as you can see, the patterns that we have found are the same. This is the shock, the nominal shock on the nominal exchange rate. This is a real shock, okay, on the nominal exchange rate, and this goes the same, nominal shock for the real exchange rate, and this is the real shock for the real exchange rate. In the next slide, I'm going to show you or explain to you what's the interpretation for this impulse response function. We can see in here that, as I mentioned before, this graph displays the cumulative impulse response functions. On the top, we have the real exchange rate. On the bottom, the nominal exchange rate. The the black pattern line is the real shock. The one in dots is the nominal shock. And we can see that the effect of a nominal shock on the real exchange rate vanishes in a short period. Okay, so this is the effect of a nominal shock. We can see that it vanishes in a short period. It doesn't have a permanent effect. The same goes for the real exchange rate. However, we can see that the effect of a real shock on both real and nominal exchange rates is immediate. We can see a sudden and permanent increase. So again, this supports the idea. These results are consistent with those found by the authors. Real exchange rate movements are caused by real shocks and in nominal exchange rate as well. And nominal shocks only have a short run, and they affect and they decay very shortly and have, of course, no permanent effect on the exchange rate movements. What I would like to do next is to complement the impulse response function analysis with the variance decomposition. We're going to go into view. I'm going to select variance decomposition, and here I'm going to report the results using a table. I'm going to select 12 periods is fine, and I'm going to ensure that I'm selecting the structural decomposition again. Okay, so just select those two options. We're going to hit OK, and here we have the variance decomposition. In this case, on the top we have the real exchange rate, and on the bottom we have the nominal exchange rate. Recall that shock number 1 is the real exchange rate and shock number 2 is the nominal exchange rate. So what we can see here is that real exchange rate, shock number 1, which is the real shock, explained, look, almost 97% of the variation is explained by the real shocks, while only up to 2.3% of the variations in the real shock can be explained by a nominal shock. So you can see that, again, the real shocks are the ones that are moving the real exchange rate in the long run. And we can scroll down and we can have the same analysis for the nominal exchange rate. We see that the real shock, explains almost 93% of the movements, while up to 6% of the nominal shock can explain movements in the nominal exchange rate. In this table, I have reported those results. We can see that here we have the real exchange rate, here we have the nominal exchange rate, and here we have the shock, real shock, nominal shock, the real shock, and the nominal shock. So in the first section, we can see that 1, 4, 8, and 12 quarters, we see that as we have already explained, 97% of these movements are explained by the real exchange rate, by real shocks, and nominal shocks on the real exchange rate only explain up to 2.37%. While for the nominal shocks, these values are 93.6%, and for the nominal shock in the nominal exchange rate, it's up to 6.39%. So, well, I hope that this video was useful, that you find this video interesting. I would like you to subscribe to my channel if you are interested in getting more content related to economics research, and also more videos replicating different research papers. If you have any topics that you would like me to cover, if you have any questions, if there's anything that you would like to ask me, I have included my email both here and in the description of the video, so please feel free to reach out. And once again, thank you very much for watching.